Good morning, seventh graders. Hey, last week on Wednesday, Thursday, and Friday, you did some scientific method water labs, and I'd like to explain three of them today. Um, so let's start with the jumping paper. Okay, so in this situation, you took your paper, this is the piece of paper right here, and you got that wet, and you got some positive and negative ions on the paper. So you had the water molecule that, let's say, look over here. Here's a water molecule. This is the oxygen, and these are the two hydrogen. These hydrogen would be the positive end of the water molecule, and the oxygen would be the negative. So that water molecule would be considered to be polarized, very much so like a magnet has a north and a south end. Well, then you had the water on the plate. So you have water in the paper and you have water on the plate. Okay, so those water molecules, when they get close to each other, are very much like a magnet that's lined up north to south. They're going to attract to each other. So you can see here that I have the positive end. So this would be the hydrogen here, and that would be attracted to the oxygen of another water molecule, and here would be a hydrogen and an oxygen. Here would be a hydrogen and then an oxygen. And so the positive and the negatives are attracted to each other. And the attraction between like substances, like one water molecule to another, is what we call cohesion. Cohesion. Okay? So in this case, you bring that water, that paper with the water in it, close to the water on the plate, and at some point that paper, because it's accordion shape, will begin to flex and jump and hop, and then eventually when you get it close enough, that paper will jump down into the water. And our next thing that you did was, one of the next two that you did was the floating paper clip. So here I'm following, this is the explanation of what happens with the floating paper clip. So this black dark line that comes like this and bends down in a little U shape and flat over here, that's the surface of the water. Okay, and those water molecules are attracted to each other by cohesion, and then they create a surface tension, a flat skim on the surface of the water. Okay, so now this is a side view of the paper clip. Okay, and you can see that this arched line right here, that would be the water bending around the paper clip. The paper clip is pushing down on the surface of the water. The attraction between the water molecules to each other, creating the surface tension, is strong enough to support the weight of the paper clip. Okay? It's strong enough to support the weight of the paper clip. So that's creating surface tension caused by the cohesion, caused by the attraction of one water molecule to another. It allows the water to bend around the paper clip. It flexes, and it does not break the attraction between the water molecules. It does not break the attraction between the water molecules. So if you look at my hands here, there's kind of a, there's maybe they're weaved together like this, and they're strong enough to support a certain amount of weight. And then as you get too much weight on there, my fingers would probably break apart. Very similar to what would happen with the water molecules here. And so that's why the paper clip is able to float. Now, if you play around with the shape of it a little bit, and I think you can still make different shapes work and things of that nature. Let's switch over to this one, which would be explaining the scared pepper. So, and this is our plate. Here we had, where the words are in the middle, we had a whole bunch of pepper on the plate. And then we put soap on the surface of the water. So the pepper would float on the surface of the water because the pepper is very, very light and it is not strong. The weight of it is not strong enough to break or separate the attraction between the water molecules caused by cohesion. When you put the soap on the surface of the water, the soap weakens the bonds between the water molecules. The soap will weaken the bond between the water molecules. So again, I'm going to use my hands. In the thing here, you can see that I kind of lock my hands together like this in front of my face. And when I pull them apart, because they're hooked together like such, there we go. When I pull on them like this, I'm able to keep them, interlocked and stuck together. Okay, but if I were to take and put some soap on my hands and try to do the same thing, the soap makes my hands slippery, and you can probably imagine that. That will make your hands slippery. And what that will also do is it will weaken the bond between the attraction between the water molecules. So water with the soap on it on the surface weakens the cohesive bond of the water to itself. So the soap gets slippery in between the water molecules, and it causes the pepper wants to stay with the water that still has surface tension. So you put the soap in the middle, and the soap starts to spread, and it pushes the pepper out to the edge of the paper. And if you had or the edge of the plate, and the pepper will stay with the water that still has surface tension. Eventually, when the soap spreads to the edge of the plate, the pepper will sink because the surface tension has been broken with the water. Okay, so those are an explanation. Those are going to be helpful in our lab for tomorrow, Tuesday, the soap motorboat, and they will help you understand and explain why the motorboat goes across the surface of the water. Very similar to scared pepper. But have a great Monday. I'll talk to you later in your during your class time. So have a great day. Bye-bye.